So in today's video, we are going to be discussing the F word, not frog, fractions. I'm going to share with you how to add and subtract fractions with unlike denominators in a different way. We're wasting time. Hello everyone, welcome to my channel, or welcome back to my channel. I am Allie Mack and I am a math teacher. So today I'm going to show you how to add and subtract fractions with unlike denominators using the butterfly method. Do frogs eat butterflies? If so, they're in trouble, right? Ribbit, ribbit. Before we get into this lesson, I need to discuss some vocabulary and some prerequisite skills. So let's get into the video. Whoop, whoop. I'd like to add that these vocabulary words are brought to you by the Maths Dictionary app. This video is not sponsored, I just like this app for vocabulary words for math. The first vocabulary word is numerator. This is the top number in a fraction. This tells how many parts are available in the whole. The next vocabulary word is the denominator. This is the bottom number in a fraction. This number also tells us how many parts are in the entire whole, and the numerator is divided by it. Now, let's talk about the word fraction for a second. This number tells us how many parts are in a whole, and it is written as the numerator divided by the denominator. Every fraction you should look at as a division problem. Start looking at it that way, like now. Come on. One more prerequisite skill coming up before we get into the actual meat and potatoes of this video, or flies and earthworms of this video.
The last of the prerequisite skills that I must show you before we can get into this video that you will not understand if you do not know this. When adding and subtracting fractions with like denominators, all you do, you add the top, so 6 plus 1 is 7, and then you keep the denominators the same. So, because look, y'all, this is like parts of a whole. So if, say, I was going to draw this beautiful bar graph, and I have 7 pieces total.
Wow.
7 pieces, right? If I go ahead and shade in the 6 to represent, you know what? Let me just use a pencil. If I go ahead and shade in this to represent 6 of the 7ths, and then I add 1 of the 7ths, you see there that this gives me 7 out of the 7, which is a whole. Okay? So that's why when you add the numerators and keep the denominators same, that's why it stays the same, because there's still that many pieces in the whole. You're just adding to it. Let's look at this next example. 1/5 plus 2/5. Same thing, y'all. All we have to do is we have to add the numerators together. 1 plus 2 is 3. And keep the denominators the same, 3/5. And if you were going to demonstrate this, you might see that this 1/5 is represented here. And then we're adding 2 to it. So when we add 2 pieces to this pie, 1, 2, you see we have 3 out of the 5, okay? So whenever you're adding fractions that have the same denominator, add the top, keep the denominator the same. Let's look at number 3. We have 8/10 minus 5/10. And let's pretend that all these pieces are equivalent. I know they're not, but let's pretend they are. Same thing as we did above, the only difference is the subtracting, okay? So we are gonna subtract the 2 numerators. 8 minus 5 gives us 3, and then we're going to keep the denominators the same. Now let me show you what that looks like. You see that I have 8 shaded out of 10, and pretend I decide that I want to eat 5 pieces. So let me erase 1, 2, 3, 4, 5. So now you see there's only 3 pieces of the 10 left. That is why that works. Okay, for this one, forgive me for not drawing a picture for this, but I think you understand it would take forever. Same principle. You're going to subtract the top. Let me bring out my beautiful calculator. 99 minus 82 equals 17, and the denominators stay the same. And since I know that this number is prime, I know it is in simplest form.
Now for the moment you've all been waiting for, let's learn how to add and subtract fractions with unlike denominators. Let's get going.
Okay, I am writing this example down twice because I am going to show you two ways to solve it. The first way is going to be the traditional way. So you will know that this is the way math teachers are supposed to teach you how to solve it. So the way you're supposed to solve this is you need to make sure they have the same denominator. And so by doing that, we're going to find the least common multiple. So least common multiple. Basically, we need to find the multiples of each one and find the smallest one they have in common. It's the opposite of the greatest common factor. So 5, 10, 15, 20. That's good enough. 10, 20, 30, 40. All right, that's good enough. And you see that both of these have a 10. Their least common multiple is 10. So both the denominators need to be a 10. This one's already a 10, so let me go ahead and bring this down here. Now this one. What can I do to make this denominator a 10? And that is multiply the top by 2 and the bottom by 2. 2 times 2 is 4. 5 times 2 is 10. So now they have the same denominator and we can add like we did earlier with those problems. What is 4 plus 5? 9. Keep the denominator the same. So this is the traditional way that teachers feel like they should teach students how to do. And it is effective. I'm about to show you another way. This way is called the butterfly. This is what you got to do. First, you're going to multiply 10 times 2. 10 times 2 is 20. And I'm going to multiply 5 times 5. Ooh, that's so pretty, and that's 25. And last but not least, I'm going to multiply 10 times 5. So that gives me 50. So, to rewrite this problem, I will have 50 as the denominator and 20 plus 25. Alright, so now I know that 20 plus 25 is 45 and the denominator is 50. I don't believe this is in the simplest form. Show you why this butterfly method works, because I don't think it's good to show you a trick and not explain or show you why. Okay, so you know we need to find the same denominator. So basically, the reason why this works is I am going to multiply this fraction, numerator and denominator, by 10/10, and I'm going to multiply this one by 5/5. It's like multiplying both of them by a 1.
Wow.
Works is you're basically just multiplying each other by its 1 in order for them to have the same denominator. So that is why this works. So same thing. Ooh, 45/50. Of 21. I know 7 plus 12 is 19. 21. So I'm pretty sure that 19 is prime. So it only has a factor of 1 in itself, so it is in simplest form. Right. Now let's try some subtraction problems. It's basically the same way. We're going to multiply this times this. Give me 24. And that times that. 18. We're going to multiply this times this, which is 27.
Wow.
24. And I almost like subtraction problems better because more than likely you don't have to simplify. Okay, so now all I have to do is figure out 24 minus 18, and that is 6 over 27. So nice. Okay. $490 over 1,000. This is gonna take some time, but let's get on with it. Divided by 10, divided by 10. That gives me, let's move this over here. That gives me 49 over 100. So really, if I wanted to make sure this was in simplest form, I could do the same thing with these numbers. A lot of times, if you have a big number like this, it's better just to divide by something you know they have in common and then figure it out from there. Like I said earlier, whenever you have numbers that are larger, it's almost better just to go ahead. Like for this one, you see how I can divide both of them by 2? Go ahead and divide them both by 2. And then that way, you won't have as many factors to sift through and all that good stuff.
Wow.
Okay, I'm going to encourage you to write these examples down, then pause the video, and then you're going to see if you are correct. All right, so we have 1/12 plus 2/3, 1/4 plus 7/8, 9/10 minus 1/3, and 8/15 minus 3/4. Go ahead and write those down and pause the video. I'm going to give you just a second to get yourself ready. Are you ready? Here we go.
Thank you guys so much for watching, and if you are still confused, rewatch the video and you will get it. It just takes practice. If you found this video helpful, please like, share, and subscribe. Go ahead, I'll wait. Have you subscribed yet? Alright, let's get on with it. Sorry. Comment down below any suggestions for new math videos you would like to see in the future. And as always, thank you guys so much for watching, and I'll see you in my next video. You all have an amazing day. Goodbye.